Target 4 has to do with working with medians of a triangle. A median of a triangle is a segment drawn from a vertex to the midpoint of the opposite side. It does not have to be perpendicular, so it's not necessarily a perpendicular bisector, but it could be in an isosceles triangle. But a median is just drawn from a vertex always and to a midpoint of the opposite side. Because of that, I can say that if I know for this problem that TA is a median, I know that 3x plus 2 must equal 5x minus 12. Or if I know that T is a midpoint because I have a median, I can set 3x plus 8 equal to 5x minus 18 and solve both of those. I can draw medians. So I plotted points A, B, and C. Actually found the midpoints. So this was the midpoint of BC in green. The red dot is the midpoint of AB, and the pink dot was the midpoint of AC. You can use your midpoint formula to find those. Then draw all the medians, so from the vertex through the midpoint. So we have a red median, a pink median, and a green median. And it appears like that point is at 1/3, 0. Then what we talked about in class was that there's a faster way to find that point on the inside of the triangle. And you can find it by doing the average of all the x's for the 3 points A, B, and C, and the average of the y's. So x plus x plus x divide by 3, y plus y plus y divide by 3. If you do that for this problem, you will also get 1/3, 0 using the x's and y's from A, B, and C. You can check out the homework problems if you want to see that being worked out. The intersection point, or point of concurrency of the 3 lines for a centroid, or for a median in a triangle, is called the centroid. The centroid has a lot of interesting factors. The first one we just saw, you can find the midpoint, kind of a triangle by finding the centroid, by doing x plus x plus x dividing by 3. The average of 2 points is its midpoint. Well, the average of 3 points is its centroid. So that's an interesting property. Another interesting property about the centroid is that from a outside of school perspective, like an architecture perspective or construction, the centroid is the balancing point of the triangle. So if I was building something with a triangle platform and I needed a support under it, I can put a main support underneath the centroid because the rest of the triangle would be able to balance on that one point. We then spent some time in class looking at the different ratios that are formed from the centroid. So I had a line mostly in pink that now has a 2 and a 4 on it, a line in red with a 3 and a 6. One of the classes I used a green line with a 2.5 and 5. And so I kind of broke these up into different types of segments. We said that the smaller segment each time was going to be referred to as the short segment. And we found out that the short segment is always half as big as the long segment, or it has this ratio of 1 to 2, meaning that the short one is either half as long as the long segment, or the long segment is double the short segment. And when I use short and long, what I'm really talking about specifically is from the centroid to the midpoint is the short side. And switching up colors, the centroid to the vertex is called that long segment. If I look at each of those parts compared to the median, I can see, let's say, take the red numbers. The red numbers, I have a 3 and a 6. And so this whole median is equal to 9 for a length. And so if I look at the short part, 3, from the centroid to the midpoint, 3 compared to 9 is a ratio of 1 to 3, or that the short segment from the centroid to the midpoint is 1/3 of the length of the median. The longer part is 6 to 9. Well, 6 to 9 has a ratio of 2 to 3, or 2/3. So the centroid to the vertex is 2/3 of the length of the median. And so we have that as a special property for the centroid. the medians of a triangle intersect at a point, the centroid, that is 2/3 of the distance from each vertex to the midpoint of the other side. And so there's some examples there for you to look at within the segments given. From the segment, or you could say the centroid is 2/3 of the way from the vertex to the endpoint. So BP, P is the centroid, P is 2/3 of the distance from B to F. And then just some different problems that are being solved. I'm going to do a couple of examples with you. So given that H is a centroid, if I know DH is equal to 2, I know that's the smaller of the segments from the centroid to the midpoint. That tells me that BH is going to equal 4, because BH is from the centroid to the vertex. That has to be double the smaller side. Likewise, if I knew HD was 5, I can double that and say BH is 10. I can go backwards with that property, and if I know BH is 8, and HD would be half of 8, or 4. The median, BD, would be 12. If I'm given the median, I can work that out as well. For example, BD, let's say, is equal to 18. Well, HD is 1/3 of the median. 1/3 of 18 is 6. BH is 2/3 of the median, which is 12, or I could have just doubled the 6 and said 12. And then the other couple of examples we did in class were showing how to set up an equation with the algebra. I know that I have the short segment and the long segment, so I have from the centroid to the midpoint E, and I have from the centroid to the vertex C. And so I know that I have to double the small part to equal the large part. And so solving that out can give me 4. For this one, I know that FB is the median. And I know that DB goes from the centroid to the vertex. So that length from the centroid to the vertex is supposed to be 2/3 of the median. So 3y minus 1 is going to equal 2/3 of 4y plus 1. Multiplying something by 2/3 makes it smaller. So I'm taking the entire median, multiplying it by 2/3 to get a smaller value, and then solving that equation. And so those are some of the basic principles of the median, and you can practice some of those in your homework.